Well, welcome back, Internet, and guys and girls. I just wanted to share what I've learned here. So I've been at this for a couple of days, on and off. I think if I were to add up the hours, maybe four hours, 5 hours. And this is something that I think everybody who has a lathe tries to do, is set up your tailstock so that whenever you're turning anything that is of any length, that you're not turning a taper. So when I had originally set this up, I was getting about 1 thou over 12 inches roughly. And I thought I could improve that. And 1 thou over 12 inches is not bad. I could have left that alone. But what I decided to do is I got some stock. And this, I believe, is, I should have brought my tape measure. Let's go and grab it. I think it's around 24 inches or so. Let's see here. Okay, well, the way I've set it up, yeah, the stock is, but between these two donuts that I made, so we're looking at 19 inches between the two donuts. Anyway, so I've noticed some guys use turn down basically just the sides here, so that you're not turning down a whole bunch of material. And it kind of makes sense, but let me tell you, the amount of work that was involved in getting a couple of pieces, boring the holes out to the right size, and it has to be pretty damn accurate. You know, machining everything, gluing it in so it's glued in with Loctite red, and overnight so that, you know, it doesn't spin. I'm not sure if that's the right way of doing it, and if it isn't, you know, please comment below, because I'm not sure how to actually do this, or how people have done this properly. I know there's gauges that you can buy that allow you to set up your tailstock, but I find that, you know, once you actually have tool pressure on the material, the actual reading is different than what you'd get in a static situation. So, you know, it's best to actually set this all up with your machine under load and seeing what the, you know, what your run out is going to be, or your deviation, and then correcting your tailstock. So, so I decided to try two things. I've tried this way to see if it goes faster, and yes, it goes a lot faster, and then you can do your adjustment. But what I'm also going to do, I'm going to make a measurement right now, just show you what I got, and then I'm going to take another cut, take another measurement to see whether or not it's consistent, first of all, because I've been finding that it's a bit inconsistent, but as long as you take the same depth of cut, it should in theory be the same. But anyway, we'll try this together and we'll see. Okay, the other thing that you got to do is, let me just take you back, or maybe you can see that right here. No, you can't. Here's another thing that I discovered that you got to do, is I got a DRO set up on here, and I've been noticing that I do my cut, and then I look over at the DRO, and it would be off by a few tenths. And that would be because there's a little bit of movement in the cross slide as it's cutting, or disengages and goes over to the other side. So you need to lock your cross slide before making your cut. So you lock your cross slide, and I can do that on this machine with this set screw, and you also lock your compound, which I can do right here. And you need to do this every time, and you'll really notice that the numbers you set it to 0 won't move, or they might only move by 2/10 compared to, you know, maybe 1 thou and a half. So really important to lock everything down as well too when you're actually making your test cuts, and keep everything consistent. I've got it, I'm going to be taking 15 thou off the diameter, so that's 7 thou depth of cut. So let's go. Okay, I'm going to unlock the cross slide so I can get this guy to turn back. Okay, there we go. I'll bring you around. So there you go, that's one side cut, that's the other side cut. The finish is really nice. I was running at 430 RPM. And that is the CCMT cutter, and with a small radius. I call it 02 because it's technically not 02. Let's see here. See if it focuses on this here. Let's see how close. Oh, that's a 04. Where's the 02? There we go. So see how close I can bring you in. So CCMT 03T302. So it's the last digit right there, the 2 that matters. So that's the smallest radius you can get these carbide cutters in. It goes from 2 to 4 to 8, I believe it is. Let's see, this one right here is can't read that. There we go. That one is a 4. So that's a medium, that's pretty much an everyday one. And then I got some 08s, I believe it is. Yep, right there, so you can see that 308. So CCMT again, 308. So that would be a much larger radius. I'm sure most of you guys know that, but for those who don't, there you go. Alright, so I've taken 3 extra readings, and the issue was, well, basically, you got to do the scientific method. You got to do this right. Taking one reading is not scientific, of course, and I thought I had it the first time right here. I thought I had it within half or 6/10, and then I did another cut, and the number was different. It was 1 thou and 2/10. So I thought, okay, well, it's not consistent. Well, it turns out that this reading right here there was probably something wrong with it. Either I misread or did something wrong. Don't know what it is, but in any kind of, real life situation, if you want to, if you want to do things right, you gotta take more data points. So here we go. So these are the 3 cuts that I did off camera, because it's exactly the same as what I just filmed before. And what is good is that at least the result is pretty consistent. So it looks like I'm just over a thou off. I got a thou taper over 20 inches there, or 19 inches. And what's also consistent is that the side towards the tailstock is the one that's bigger every time by a thou, roughly. So that's also good. So what I'm going to do is I'm going to actually move, and I'm going to just show you how I actually do this. So I'm going to move because this is bigger, it means that the cutter is, let me think this correctly, is or the tailstock is too far out. Therefore the cutter is further away from the stock, making a larger part. So I'm going to need to bring the tailstock in half of that error, so that's a half a thou in towards me, and that should reduce this size, hopefully be within the spec that I'm looking for. And I'll just set the camera up and show you exactly how I do that. Alright, it's really tight quarters here, but I think you get the idea. Alright, so the first thing I do is I'm going to release the quill. Okay, I don't have to worry about the stock falling because it's still in the chuck. And that's one thing I forgot to mention. Every time I undo the tailstock and then reset it, it's really, really important, and I should have said this earlier, it's really important to go back to the chuck and re-chuck the stock, because the chuck is actually gripping onto the material in a direction that was in line with the tailstock at the time. So every time you change the tailstock, you need to re-chuck the material so that it aligns properly. Anyway, so first thing here, I got the quill lock off. I'm going to loosen up the tailstock. So the tailstock quill can come back out a little bit. I'm going to set up a DTI. I don't know if you'll see it on camera, but it's basically this half thou indicator, DTI, on a little Noga stand. And it might be out of the frame, but I'm going to stick it on here. This camcorder I have doesn't zoom out enough. I think I might get something else, you know, down the road. There we go. So, yeah, you might see it in there. I'm going to adjust this so 0 is there, right in line with my eyes, right there. And I am looking to bring the tailstock in towards me by 5/10, so a half a thou. So that means the needle needs to come this way, or needs to swing this way by half a thou. There we go. And what I'm going to do now is I'm just going to gently release pressure on one of these set screws. Oh, wrong key. Here we go. And see which way this goes. Hopefully, no, that's going the wrong way. So I'm going to tighten it. Yeah, I can tighten it, and it does move. So I've just tightened it so that the indicator did just move a half a thou. You probably can't see it, but it did move a half a thou, and that's all I'm going to do with it. Yeah, I'm not going to loosen it up anymore. I'm not going to do anything else. There was still enough play in there that I could crank down a little more to get a half a thou movement out of it. So that's good. That's all I'm going to do. And next is I'm going back to the chuck, so I'll reset the camera here. So you see what I'm doing. So next I'm going to go back to the chuck. And I'm going to unchuck the work. I have to be careful that it doesn't fall. There we go. Okay. Hold this here. Lock this in place. Push the stock up against the tailstock now into the cone so it's centered. Tighten up the chuck. Rock on it. Now I'm going to put some pressure on the quill by turning the handle. You don't see that, but I'm, let's see. Let's see if I can move the camera around here. Now I'm going to put some pressure on the quill here, and then lock the quill in place. So now we're set. And we'll do another cut. But what's really interesting, that what I've learned basically, I'll cut down to the chase, is that you would think that whenever you make an adjustment on your tailstock, and the adjustments I've been making here are under a thou, so for the most part, when we're getting down into the nitty-gritty stuff, as things are getting closer and closer, I'm going half thou, quarter thou. So basically I'm trying to move the tailstock in tenths. And sometimes I would do that, and for example, in this case right here, I would move the tailstock what I think would be 2/10, or it is 2/10. But in actual fact, what it ended up doing is I ended up cutting the difference between +6 and 0.2, so 6, 7, 8. So that's almost a full thou, just 8/10. So that's 8/10 of a difference instead of 4/10. It's basically 2 times the amount of deflection. So that's basically double. I ended up cutting double, and that's unexpected. You would think that you would dial in a certain amount on your tailstock, and double that would come off of your diameter, right? It doesn't always work out that way, so you kind of have to massage things in and out, because I think what happens at the tailstock itself, it's big piece of cast iron, and you're making these adjustments under tension. like I said, you don't want to completely loosen them because you'll be totally off. So you're doing that under some tension, not, very, very little. This guy's basically off. But I think what happens, there might be a little bit of built-in tension in between the top part of the tailstock and the bottom. There's probably some settling, especially once there's load applied, lateral load applied to the quill and to the actual tailstock itself. Anyway, that's just my theory. I have no idea. I really don't know what I'm talking about, but I just wanted to show what it took here to get the tailstock lined up. Wasn't as straightforward as I thought, and there are a few procedures, like I had mentioned earlier in the video, that need to be followed pretty closely in order to get consistent results. And that, of course, is every time you loosen up the tailstock, the quill and the tailstock, make your adjustment, and then release the pressure on the jaws and re-chuck again as well too, so it aligns itself properly. And then I was getting consistent results, and I didn't know that before. I've never read about that or seen that on YouTube, at least not from the videos over the past 5 years that I've looked at. So anyway, this seems to be pretty good. My next video, I guess I'll try chucking in some other type of material, that longer shaft, and see what kind of deflection I get. This was set up with a 7th depth of cut all the time, the whole time, and I thought that was a good average. Typically when you're dialing in your last thou or so, you're taking very, very lighter cuts, so in theory things should be better, but they can change. Anyway, hope that helps somebody. We'll catch you later.